Hello friends, welcome to my channel. Today we're going to talk about routing policies in Route 53. When you create a record, you choose a routing policy which determines how Amazon Route 53 responds to queries. So based on that, there are 5 major routing policies in Route 53, starting with the simple routing policy, weighted, latency, failover routing policy, and geolocation routing policy. Now let us see what each one of these are used for. The first one is simple routing policy. These are used when you have a single resource application. So we have seen this in our previous video where we have assigned the IP address for a DNS name and we have used simple routing policy for that. So this is the most simple and default routing policy in Route 53. The next one is the weighted routing policy. Especially these policies used when you have a special scenario where you want to route the traffic to different servers based on needs. Say for example, you want to route 70% of the web traffic to one server and remaining traffic to another server. In that case, you can use weighted routing policy. Let us see with some example. Say for example, you have a server where you have deployed your application with some latest features, but you're not sure whether to release this to the entire population. So you have deployed this new version of your application in one server, and then in other server your existing application is running. All right. And what you want to do is you just want to test this application to a fewer percentage of the population, say for example a beta stage. So you route the request to this, oops, so you let me select an arrow here. So you route the request to this server where you have deployed your new features, and you are also routing this traffic to the older server where the existing application is deployed. So since you don't want the entire population to use your new features, you assign a weightage. You say something like, okay, let me give 30% of the traffic to the server where the new features are deployed, and remaining 70% of the traffic should go to the server where my existing application without the new features has been deployed. So this is called weighted routing. So here goes the 30%, and here you're trying to push remaining 70% of the traffic. So based on this, you can decide how much percentage you want to route to which server. So when you use this, basically, if you see some of the applications like Facebook, whenever they release a new feature or a new change in the UI design, they don't release it to the entire population. They just deploy the new features in a new server, and only certain users in the world will be using that particular feature. So they use it via this weighted routing policy. So you can decide at what proportion you want to send the traffic to which server. Now let us go back. So you can assign the weight based on the numbers from 0 to 255. You cannot give a number more than 255. It will throw an error and it will not allow you to enter any value beyond this. Okay. So the next routing policy is called latency routing policy. So latency routing policy you use when you have resources in multiple AWS regions and you want to route traffic to the regions that provide the best latency. Say for example, I'm a user from India and there is a server which is running in Mumbai region and there's another server which is running in US region. So automatically when I hit the browser, it will take me to the server which has the less latency. So since I'm in from India, it will always direct the traffic to the server which is deployed in Mumbai region. The next routing policy is called geolocation routing policy. You use this when you want to route traffic based on the location of users. Say for example, your user is from India, all the users from India will always be routed the traffic to the servers which is located somewhere near the Indian region. Either it could be a Mumbai or either it could be a server which is deployed in Japan region. So whichever is the closest proximity, the traffic will be routed to that particular region. So we will see this in more detail when we see a demo. The next routing policy is called failover routing policy. You use this when you want to configure active passive failover kind of a location. So in this case, you have more than one server. One server will be treated as a primary server and all the requests will be routed to primary server. When primary resource goes down, then it will automatically transfer the request to the secondary server. So we will see this in another demo. Now let us go back to our AWS console. Okay, now let us first see a demo on weighted routing policy. As we discussed before, weighted routing policy is used when there are multiple resources for the same functionality and the traffic needs to be split across resources based on some predefined weights. Right? So before we go any further, let me first attach the name servers of this particular domain which I have created using Route 53. Let me click on registered domains. So here we need to attach the name servers. So let me click edit name servers and let me create a new window. To attach a name server, we first have to create a hosted zone. So click on create hosted zone. And let me give the domain name here. So my domain name is vn-cotube.de. Alright, so let it be public hosted zone. Click on create. Now these name servers I need to copy. If you have remembered our previous video, we did the same exercise for Freenom. We are going to do this in Route 53 now. These are the second name server. It's the third one. And here it goes, the last one. Now let's update it. Now our DNS configuration is done. So next thing what we have to do is create a new record set for our EC2 instance. So create new record set. I won't be giving any name. Let me reduce this to 20. And here I need to give an IP address. So what IP address can I give? Let me go back to my EC2 instance. So currently we are in North Virginia. Let me start all my instances. All the instances are now running. So let me select the first instance, copy this IP address and go to the browser. So this says welcome to USA 3 and let me also check another one. This should show me welcome to USA 2. So we are going to do a small exercise where I'm going to route the majority of the traffic to USA 2 and a small chunk of traffic to USA 3. Let me go to my Route 53 and create a new record set. So let me reduce the time to 10 and copy the IP address. So first one is 161. And then select the routing policy as weighted. Give some number. So let me give a number like 100 and the set ID as the same what we are displaying in index.html and click create. Now create another record set for USA 2 remove these HTTP messages, change the TTL as 10, routing policy as weighted. Now for the previous one we gave the weightage as 100. Let me give something like 20. We can change it later if we want. And this is welcome to USA 2. Ideally, when you give a set ID, it should be a meaningful description, like in which region you're deploying, right, on what it means. But for demo purpose, we're just giving the same what we can see in the index.html. Click on create. So now our record set is created. Now let us verify once. So whenever I hit the domain name, it should always take me to the IP which will display welcome.usa3 because the weightage is 100. Let us test this. As we expected, it is always taking to USA 3, and if I refresh, it should still take me to USA 3. Maybe 2 out of 10 times it might route the traffic to the IP where we are displaying USA 2, but that's very difficult to show in the demo. So most of the time it will always route the traffic to USA 3. Now what we can do is we can change this weight and we can check once more. Let this be the same. Let me increase the weightage of this. Let me give some value as 250. Now if I try to give 256, it will not allow me because 255 is the maximum range. So I need to give some value equal to or less than 255. Now I have given the maximum weightage for this IP. Now let me refresh the screen and see whether it is taking me to this particular IP address, which is the one which you can see on the screen. Now the caching is reduced like to 10 seconds. So the moment I refresh, you may not be able to see the changes, but after a couple of seconds, yeah. So since we have given the TTLS 10, it is now routing the traffic to USA 2. Now if you want to still play around with this, you can again change it back to 2, and now it should route the traffic to USA 3. So it is still picking it from the cache. So let us give some moment. Count till 10 in your mind. It is taking the traffic to USA 3. So this is how you configure a weighted routing policy. So I hope you're clear with the concept. Now let us see another routing policy. Let's talk about latency routing policy. Latency routing policy is used when there are multiple resources for the same functionality and you want Route 53 to respond to DNS queries with answers that provide the best latency. That is the region that will give the fastest response time. So that is the latency policy. So if I have to draw an example for you, say for example you have created a server in Mumbai region and then another server in Singapore region or American North Virginia region, and then the user is placed somewhere in Mumbai region, or let me draw it here, and based on the latency the network traffic should be routed to the server which has the closest latency. So in our case, since our user is situated in Mumbai, which server you think will give you the minimum latency? It's Mumbai server, right? Because he is in Mumbai, and so the server which is running in Mumbai will give the less latency compared to the one which is deployed in US region. So the routing policy here will automatically pick the server which has the very less latency time based on where the user is accessing the browser, and it will route the traffic to that particular server. So now let us see a demo on this. Now we have, let me delete these records. Okay, so we have EC2 running in US region already. Let me also create something in Mumbai region, Asia Pacific Mumbai. Let me start the server. Let me copy the IP of this and see what message you're able to see on the screen. This should show welcome to Mumbai region. Fantastic. Now let me go to Route 53 and start configuring. So let me copy one of the IP address of the EC2 which is running in US region. Let me copy this IP. Go back to Route 53, create a record set, copy the value here, give the TTL time as 10. Here select latency. Now you can see automatically it will give me the region where this particular server is running. So since this server is running in US region, it is automatically selecting US East -1. Let me give some site ID. I would say US region and click on create. Similarly, create another record set and copy the IP address of the server which is running in Mumbai. Let me go back, copy it here, reduce the TTL to 10, and then select the routing policy to latency. Automatically it should specify AP-south, and let me give something here. I will say Mumbai region. Now the reason why we are reducing this cache time so that I can show a demo on this, but ideally in production it is always better to keep a higher TTL time. All right, so let me create this. So now which server do you think the request will be routed to? Whether it will be routed to the US region or the Mumbai region? Since I am located in Bangalore, the nearest latency for me would be the Mumbai region. So let me test it. As we expected, it is routing to the server which is running in Mumbai region. Now to verify whether this logic is correct, you can go to AWS latency test and you can go to the first link. You can also go to CloudPink, whichever any website of your choice, and click on test. This might take some time, so let me go to the different one. CloudPink, oops. CloudPink could give me some faster results. Click on HTTP ping. So let us see which server gives me the least latency. So we initially tried in US East, it is 224 milliseconds, and the Mumbai region is 37 milliseconds. So it's pretty obvious why the Route 53 has routed the traffic to Mumbai server. So guys, this is how you use or you work on latency routing. The next routing policy is geolocation. Geolocation routing policy is used to route the traffic based on the geographic location from where the DNS queries originated. So this policy allows to send the traffic to resources in the same region from where the request was originated. That is, it allows to have site affinity based on the location of the users. Let me draw an example. So for example, you have a server. This is deployed in US East region and another which is deployed in European region. So let me see if I can write. Let's assume this is US region and this is deployed in European region. And here we have our Route 53 and we have two users. One user, he is from European region and another user, he is from US region. So when the US region is trying to Yep. So when the US region is trying to hit the route 53, the request will be routed to the servers which is deployed in US region, and when the user from the European region is trying to hit the browser, the route 53 will route the request to the service which is deployed in European region. So this is mostly based on the affinity, right? So when I say European region, it could be anywhere. It could be in so let just give me a minute. So what are all the European regions do we have? So in Europe, it could be either in Frankfurt or Ireland or London. So if the server is deployed in Frankfurt and the user from London is trying to access, it would route the request to the nearest one, which is Frankfurt region, right? So this is how geolocation routing policy works. I'm not sure how I can show you a demo because since I am from Bangalore, it will always take me to one particular geological location. But still, let me try showing you how to configure a routing policy based on geological. Let me delete this record sets. Let me delete this as well. Now let me copy the IP address of one of the EC2. Let's go back, create a record set, give some value as 10, and here select geological. Choose a region where you want, and let me say, since this is deployed in US region, let me say all the users from North America should be routed to this particular server. So this is for North American users. All right, so let me create it. And then let me go to the Mumbai region and create a new record set. Select geolocation and select the location as Asia. So any user from Asia should be redirected to this server which is running in Mumbai region. Now since I am from India, which server do you think the request should be routed to? It's obvious, right? So it will be routed to the Asian region. So let me test this. Let me close this browser and it should take me to Mumbai region, right? So if you're still not very sure, let me revert this. Let me say instead of Asia, let me say all the users from Africa should be diverted to this, and all the Asian users should be directed to the North US East region server. Let me select Asia. Okay, so now when I try to access the same website, it should show me welcome to USA 1, right? Let us test that. So this is how geological location works. So whenever we have configured in a way like all the Asian region users should be directed to US East 1 server. So that's the reason it is redirecting to this particular IP address where I am displaying welcome to USA 1. So guys, this is how geological location works. Now let us look at some other routing services. The next one is failover routing policy. Now failover routing policy is used to create active passive kind of a setup such that one of the site is always active and serve all the traffic while the other side remains as a disaster recovery zone, like a standby server, right? So Route 53 monitors the health of the primary site using something called health checks. So if I have to draw a diagram, Let me delete this. So you have a site which is a primary site, and then you have a standby site, right? And then you have a user. So this primary user, sorry, the primary site is somewhere in US region, and the standby site is located in European region. Let me change the color. So now what happens? Now I'm still not used to this tool, okay? So now when the user or when any request comes to the server, it always sends 100% of the network traffic to the primary zone, and it does not send any request to this particular zone. So let me write here 100% of the traffic to primary and 0% of the traffic here. So why does it not divert any traffic? Because this is just a standby, right? This is not used to serve any request. Since this US region is the primary, all the 100% of the network traffic will always be directed to this particular US region. So what happens is that we are assigning something called health check. So this health check will keep checking the status of the server, if it is healthy or not. If for some reason this server goes off, goes shut down, then immediately the European region will be made a primary, and then the network traffic or the internet traffic will be routed to this server which is running in European region, right? So this is how failover routing policy is. So it will always make one server as primary, another as standby, and based on the health, it will make the standby as primary when the primary goes down. So let us see a demo on this. Let me delete these records. And now we have to configure our health checks. So let me go to health check. Click on create health check. And here you give some name. Let me say web server health checker. And here you need to specify what do you want to monitor, whether you want to monitor an endpoint or do you want to monitor the status of other health checks. Like this will be considered as a parent health check, and the other health check whose status you're monitoring will be a child health check. So we call this as calculated health check. Or you want to monitor the state of a CloudWatch alarm. So let me give endpoint. And here let me select IP address or domain name. Ours is IP address. Protocol would be HTTP. And what is the IP address? IP address of this is, let me copy it here. And now what is my host name? Let me copy this host name. Let me delete this HTTP. And port would be 80 and path would be index.html. Alright, so we are almost done with our configuration, but let me go to advanced. So request interval is something, what is the frequency at which the health checker will ping the server and get the status? So by default, the interval is 30 seconds, but if you want a fast response time, then you can choose 10 seconds. Failure threshold is something, if it fails consecutively for 3 times, then it will mark the status as unhealthy. So for now, let me reduce it as 1. And these are nothing but whether you want to create a graph or stuffs like that. We won't be changing any of these. Health checker regions is by default AWS provides a health checker region running in these regions. If you want a customized one, you can change it. But let it go with the default one and click on next. Do I need to create an alarm? No, I don't want to create an alarm. I don't want to send an email or a SMS notification. So let me select no, create a health check. So now health check is created. So currently the status of primary server is healthy. Now let's go back to our hosted zones and click here. Let us create a record set. Click on create record set and let me give the IP address of my primary EC2 instance. Let me copy this, go back, and let me reduce this to 10 seconds. And let me select failover routing policy. Is this my primary instance? Yes, it is. Let me associate this with a health check and web server health checker. Click on create. Similarly, let me create another record set. Let me copy the IP address of my standby server. Let me reduce this to 10 and failover. Is this my primary? No, this is my standby. So let me select secondary here. And I won't be associating any health check for secondary. So let me click on create. So now we have two records in the record set. So when I click on my domain website like vian-codetube.de, it should always route the traffic to the primary EC2 instance. So I should be seeing something like welcome to USA 1. Right now let us test this. Let me refresh the screen. So it is sending the request to welcome to USA 1. So no matter time how much ever I refresh, it should always route the request to USA 1. Now let me terminate or let me stop the EC2 instance and then let me see how it behaves. Let me go here, let me click on primary, click on actions and stop this EC2 instance. Meanwhile, let me go to health checks and let me see whether the status is being changed to unhealthy. Currently it's showing healthy. Let us wait for some time. So we think we have configured it will ping the server every 30 seconds. So we need to wait at least for 30 seconds. As the server stop, no, it is still not at stop. Now it is stop. So yeah, it should change the status anytime. So the status is now updated. It is now showing unhealthy. Now let me go to my website and see where does the request is routed now. So it is now routing to the standby server, which is welcome to USA2. So what the Route 53 did is, since the primary EC2 is down, it made the standby as the primary. Right? So this is what happened behind the scenes. So initially this was primary and this was standby. The moment I have shut down the system, the status changed to unhealthy and the request which was initially being routed to primary, now it started routing to the standby server. So guys, this is how the failover routing policy works. Friends, thank you for watching my video. If you like this video, please share among your friends and don't forget to subscribe and hit the bell icon.